A model does not adjust one number, it adjusts millions all at once. So we need calculus for functions of many variables. The key object is the gradient, a single arrow that points in the direction of steepest ascent. It is how a model knows which way is uphill in a million dimensions. Start with a function of two inputs, a landscape of hills and valleys. At any point, we can ask two separate questions. If I step east only, how steep is it? That is the partial derivative with respect to x. If I step north only, the partial with respect to y. Each partial holds the other variable frozen and measures slope in just one direction. Collect those partial slopes into a vector, and you have the gradient. For our landscape, it is the pair, steepness east, steepness north. Written with an upside-down triangle, del f. It is not just a list of numbers, it is an arrow living right there on the map at every point. And that arrow has a remarkable property. The gradient always points in the direction of steepest ascent, the fastest way uphill. Its length tells you how steep that climb is. Stand anywhere on the landscape, read the gradient, and you instantly know the single best direction to increase the function. There is a beautiful geometric fact here. Draw the contour lines, the paths of constant height, like on a topographic map. The gradient is always perpendicular to them. It never runs along a contour, it always cuts straight across, taking the most direct route up the hill. Now connect it to learning. A model's error is a function of all its weights, a landscape in millions of dimensions. The gradient of that error points in the direction that increases the error fastest. So to reduce the error, we go the opposite way. The gradient is the compass, we simply walk against it. So, gradients and partial derivatives. A partial derivative is the slope along one axis, the gradient collects them into an arrow. That arrow points straight uphill, perpendicular to the contours. Flip it around and it points toward lower error. Which is exactly the algorithm we build next, gradient descent, Chapter 16.